So welcome to From Zero to Application Delivery with NixOS. And we're going to be looking at how we can solve some of the key problems with application delivery along the way, from project inception all the way through to actually delivering it to production. And that will include things like having reliable development environments, consistent CI dependencies, so no more out-of-band sort of chef converging on CI builders just so that your particular branch that upgrades Redis is going to be able to run appropriately, as well as predictable deploys. So who am I? Here are some of my biases. I did a fair bit of work with Ruby a while ago. For some reason, people have endorsed me and continue to endorse me for Ruby. I don't know why. But actually, my more recent experience has actually been a bit more in functional programming. So a little bit of Erlang, Haskell, and Scala. And you'll see one of the things that I'm actually very proud about in terms of my endorsements is hating Jira with a passion. You can't read the full thing. So 9 people have endorsed me for this. So the agenda for today is that we're going to explore the problem space for the set of problems that Lookout. So I work for Lookout in infrastructure engineering, and we're going to look at the kind of problem space. We had a number of different services that we needed to deliver to production. We wanted to be able to control the infrastructure, so an externally hosted platform as a service wasn't really going to work for us. We also have a variety of different stacks that we need to support, and a variety of other concerns that I'll go into a little bit more detail in a minute. And we wanted to be able to manage our infrastructure more consistently and more predictably. So I'm going to talk a little bit about a path towards reliability. This is based and predicated on my bias of functional programming. And then we're going to look at how Nix can provide solutions using that basic design tenet. And so the common problems that we'll explore is how to get repeatable development environments, consistent CI dependencies, and predictable deploys. So a little bit of framing first. So at Lookout, we had previously been using Chef to manage some of our infrastructure. We were in a data center, and now we've moved to AWS. That was kind of an independent thing to moving away from Chef. But one of the problems that we consistently had with Chef and before that Puppet was that it only really provided a partial definition for our infrastructure. And so, for example, apt sources or Yum repositories change out of band. So if you do a Chef converge on a set of systems, then you may get the same result, but you may not, right? And it's totally dependent on these external things, right, that you depend on. And so also, most package management systems are predicated on shared mutable state in shared file system directories. And that leads to a number of problems. And then hopefully it converges, but it doesn't guarantee that, right? So you define all of your assertions about your system and your resources that you want to achieve, but they're not always met, right? And this isn't specific to Chef. This applies to anything that's convergent, right? Convergent configuration management system. This isn't to say that it's a wrong choice for other people. It's just we kept on having a whole bunch of problems. And we'd rather not have them, right? So, and overall, we didn't feel it was reliable enough for our standards. So, a quick word on reliability. There's someone who had a talk some time ago, and this person said this: those who want really reliable software will discover that they must find means of avoiding the majority of bugs to start with, And as a result, the programming process will become cheaper. So the person that said this, I'm probably going to alienate half of you by showing you who, but it was Dijkstra, right? And he said this in 1972. And this is something that I still think is prevalent today, and it's often ignored, right, by a lot of tool sets and, that we utilize today. And if you want to look up, it's called The Humble Programmer, and there's a great there's a transcript of this. I really recommend people read this because it's just as pertinent today as it was in 1972. So why should we care about reliability now? Well, I think there's really three factors. There's economic, human, and technological. Right? Number one, economic factor is that we have to deploy distributed systems. And we have to rely on them, right? We can't actually solve the vast majority of our problems with single host computers or software anymore, right? That's just not an economic reality. And in terms of human factors, we have a really high turnover in operations, at least, and also in engineering for similar reasons. And the quality of work life inside of operations tends to be fairly low, right? It's a lot more reactive work rather than proactive work. And that's something that our team really wants to change so that we can get a much higher return on investment from our infrastructure and our tooling and process. And then technologically, right, we have programmable infrastructure. We no longer have to do all of the setup for building our data centers and all of that sort of stuff if we don't want to, right? There may be a point where we actually want to do that work because there's a good return on investment. And then the other factor here is that functional programming is no longer just for academics. There are a number of functional languages that are just as efficient, if not more so, than a large number of mainstream imperative languages and runtimes. So that's no longer a consideration. It was, in the 70s, 80s, even 90s, right? So at Lookout, we need to, our drivers were that we needed to support a whole bunch of services, right? We currently have 20 to 30 services right now. We're looking to get to about 50 services by the end of the year. And this is partly due to the fact that we have a consumer offering and also an enterprise offering now. And so we're kind of launching all kinds of new services all the time. And we run on a variety of stacks and runtimes. So we have to support a number of different stacks and runtimes. We are primarily like Ruby, JRuby, and Scala centric right now. We need to be able to provision new environments, whole environments, not just deploy a service to a specific already set up environment. This is for a number of reasons. We need to be able to do ephemeral testing for high-risk changes so that we can launch everything in an automatic CI hook and tear it down all at the same time, and verify that the infrastructure gets built the exact same way that we expect it to, right, in terms of our assertions and things like that. We also have multiple product lines now, so there's some segregation in terms of environments that we'll need, and we need to be able to launch performance environments whenever we want to do an experiment, whenever an engineer wants to be able to do an experiment. And we also have partner agreements where we need to launch brand new environments from scratch just for those agreements. And we have to support a whole bunch of data services and persistence systems, right? So anything from Kafka, Redis, Memcached, all the way to MySQL, Hadoop, Cassandra, all of these things. My team is actually responsible for that, right? And so we can't just rely on the typical immutable infrastructure solution, which is just to replace all of the nodes and behind a load balancer and then you're done, because that works for stateless services, right? Applications and things like that, but not so much for data services, right? We actually have to think through how we can actually do better update in place kinds of deployments on the data services. And so here are the problem statements, right? We have environment provisioning, right? Well, like when I started at Lookout, environment provisioning was not at all repeatable. In practice, there was a lot of tribal knowledge, right? People doing things by hand. So continuous integration breaks, builds break when an application changes its dependencies, right? It changes from one version of MySQL to another or something along those lines, right? And we had deploys doing things that we totally didn't expect. And that's partly because you can't do a total dry run with a lot of the tools that we had been using. So when you do a dry run, it doesn't trigger all of the things that it would actually do when it applies the changes in the environment, right? It can't really do that without some various design choice changes, right? So, okay, so we were looking to optimize for scalability, and for that, we're solving it, so to speak, by using an on-demand cloud. We've moved to AWS, right? So that's not really the topic of this talk. It's really more about how do we make our configuration and managing our infrastructure more reliable. And so how do we solve reliability? So I'm going to contend here that what yields reliability in software is the ability to reason about our code. And so what allows us to reason about our code? Here's where my functional programming bias really shows, and it's referential transparency. This is what I'm going to say. Okay, so referential transparency is just a fancy word for saying functionally pure or pure, right? That's all we're going with, right? So I'm going to just go through something very non-academically, right, with some code examples, right? I don't think I'm going to say anything that's very controversial here. So I'm just going to start off with these primitives, these functions, right? They have inputs, right? So we have this functions module that I've defined that has two functions in it, right? And we can add integers and we can find the length of a string. This is not too interesting. We can do the same thing in Nix, with our Nix expression, by defining lambdas in the let expression, in the let binding. And then we sprinkle it inside of this attribute set, which is kind of, you can think of it as a module for this purpose. And so, again, Ruby example for any Ruby people, and in JavaScript, we just have these functions, right? This is really not that exciting. So, but Nix really is not just an expression language. It's also a way to define packages and to manage packages and manage package dependencies. And so here, this is a definition of the hello package, which there's actually a hello GNU project, right, which this is using, right? So we define so the third line here is actually a list of named inputs. So we've got standard env, fetch URL, GCC, and help to man, right? The last two are actually packages, and the second one, fetch URL, is a function that's provided by like the Nix packages ecosystem. And standard env is a set of like objects or things like that. So you can think of it as kind of like a module that you can pass around, and it has some goodies inside. One of those goodies happens to be make derivation. So you'll see in the line that starts with in, we use this function, this lambda, in Nix terminology, make derivation. And then we just assign a whole bunch of attributes, right, to build to go ahead and build this package, right? Now, you'll notice also that build inputs, here we actually provide GCC and help to man as inputs for the build itself, right? And that'll become more interesting later on. So functions return a result. I think this is very not controversial again. it returns a result. And in Nix packages, so in the Nix world, what does that mean? What does it mean that it returns a result? Well, if we've got a package definition, we can construct the package as we do in the middle here, where we do hello equals, and then we import the file that contains the Nix expression for the package. And we supply it the arguments, which happen to be in the scope right now because we've loaded all of the Nix packages environment in our REPL. And then at the bottom, you'll see that if we just try and see what that hello variable is bound to, it's just this lazy value of a derivation, right? And then here, we can actually force the evaluation of the hello package value, and it will result in a path, right? And this is a path in the Nix store. And the ... has like, a whole bunch of characters in there for the rest of the hash. But basically, a cryptographic hash is computed for a package based off of its dependencies and its build command and so on and so forth. So that every time that you're building a new package, if the version changes or the way that the package is actually built changes, then it will be a different cryptographic hash, right, in that path. And that'll become important later on. So, so we can also see that if we build from the command line on the second half of this code slide, we actually get the same Nix path, right? And we're using the exact same inputs, right? And we get the exact same path. So when we build expressions and lambdas or functions, right, or package definitions, right, we have to only depend on the inputs that we're given, right, that we explicitly set. And so let's take a look at what if we just removed help to man as a named argument from the definition that we saw earlier. Well, if we do that, then we get the error at the bottom, undefined variable help to man, because we're trying to use it later on in the definition. And then, okay, so that's expected, and I think that's good, right? We're eliminating a class of bugs at this point, right? If we try and build a package that we don't give it all of the inputs that it actually ends up using, then it should result in an error. That's something that I would want, right? To eliminate a whole class of bugs and not depend on the builder's environment to begin with, right? So what if we removed help to man from the build inputs? Well, in this case, it starts building. So you might think, oh, well, that's not good, right? But then in the end, it actually errors out, right? Which is actually what we want, right? We don't actually want it to result in a Nix path with a built binaries inside of it. What happens here is inside of the build command, it's trying to use help to man. But of course, when it gets to that point, it's not in the path or the environment, so it fails, right? So in this case, this is good because, again, it fails, right? Not necessarily on interpretation, but when we're actually trying to run it. And so we know that we've got a missing dependency somewhere, right? In our case, we haven't set the build inputs appropriately. So another part of referential transparency and purity, functional purity, is that the same results, so we return always the same result every time we're given the same inputs. And this is really important for being able to reason about our code. So I give the same string to len, and it returns the exact same answer every single time, right? Now in Nix, in Nix world, as long as we're using the same Nix packages version, like the whole channel, then we're going to be passing on the same arguments every single time on this command line. And it will result in the exact same path and the exact same binaries that are produced every single time. So that's the big idea, right? Referential transparency. Always, given the same inputs, we always get the same result. So, questions so far? Yes? Oh, this was building a package. So, great. So here, we actually defined a package in this Nix expression. We're using this make derivation function from standard env, and we just define like a bunch of attributes, right? And inside of make derivation, it does stuff like with help to man and a few other things. Yes, yes. And here I did omit the fetch URL, right? The expansion of the fetch URL, which is just two attributes, right? It's the URL of the source and the SHA-256. Yes, no, great question, thank you, thank you. Any other questions? Okay, so mainstream package management, right, is really based on shared and mutable state on the file system. And who here programs concurrent systems, distributed systems? Who here thinks that's a great idea? Okay, we're in agreement, okay. So, this violates referential transparency, and this is how I feel whenever I have to use these mainstream package management tools, right? So what are the alternative approaches, right, that don't necessarily violate referential transparency? Well, one is shared and mutable. So you can share immutable structures all you want, right? That's not going to be a problem. You can make your mutable areas private so that only one thing acts on that mutable area. So that's kind of how Nix sets up the build environment. There's only one thing that can actually access that mutable area, right, during the build. And you could do some kind of expensive coarse-grained locks. That doesn't necessarily result in correct behavior unless you handle all of your error cases nicely. That's not necessarily my experience with these kinds of systems. Or you could use some kind of some kind of hybrid without the expensive coarse-grained lock and maybe use finer-grained locks, right? And in fact, we'll see that Nix uses symlinks, which is kind of a very fine-grained atomic operation, right? Kind of like a lock, to be able to mix in things to your path, right, and to your environment for different profiles. And so Nix defines all of its inputs, right? So it uses chroot to build all of the packages. You can, it requires that you are explicit with all of your inputs for the packages. This is just on the package management side, and we'll get a little bit to machine definition towards the end of this talk. And then we've got this full dependency definition, right? So we no longer have this partial definition that we had with our convergent systems before. And to ensure referential transparency, it keeps the build area private, and it can mutate that area, right? And then different inputs will result in different results, and that's an important thing. That's different to the same inputs give us the same result. This is actually important, though, because then we don't clobber anything in the file system, right? Every time that there is a change to the package definition, it will result in a different path. So it's not going to clobber like a previous build or a previous definition. And then it symlinks the results into the profile. So that's the finer-grained lock using this atomic operation on the file system. And so this makes it a congruent sort of system versus a convergent one, right? In terms of the package management part itself, right? And so a couple of notes, right? There's a little bit of confusion about some of the Nix kind of ecosystem. So unfortunately, the package manager and the expression language are both called Nix. I don't know why, but that is the case. So depending on the context in which you're using this, Nix will mean either the expression language or the package manager, right? There is an ecosystem for called Nix packages, which is very similar to Ubuntu sources and universes and stuff like that, right? Different repositories in Yum world and stuff like that. It has a very good collection of packages. I rarely find a need to actually add new packages unless I need to do something weird and interesting for that particular package. So most open source things I've not had to create my own packages for. There's thousands and thousands of packages in here. And the operating system itself, right, is based on Linux, and it's called NixOS, right? And this, and we get to define our configuration for the whole operating system, the whole node, using the Nix expression language again, right? And it uses the same kind of dependency management mechanism. So the configuration of the hosts use this thing called a module, which allows you to kind of abstract away a number of details. So, for example, you can have a Cassandra module that will, you can specify the package version, the package for that Cassandra installation, and it will set up the systemd service for you and a whole bunch of other things, right? To set up the appropriate ownership of certain data directories and things like that. And it's a very simple kind of language, and we'll see an example of this later on. And then there's these three down here, Nix, for provisioning, orchestration, and CI. I'm not really going to cover that much in this talk because, well, we do use NixOps, but for AWS VPC-based stuff, I don't necessarily recommend it. And then the orchestration piece, we've really not had any experience with. And CI, the Hydra offering, we're actually quite happy with, except for practical reasons, we had to use NixOS Jenkins builders because developers didn't like Hydra. So let's get to the problems, the three fundamental problems that we were talking about earlier. So repeatable development environments. We're going to start off lightly, and there's a tool that comes with the Nix package manager called Nix Shell. And what this allows us to do is to load up an environment where we have Erlang R17 installed, right? This is the name of the package inside of the Nix packages channel. And so we can do that by just launching this command, nix shell -p, and then the name of the package. And what it'll do is it'll calculate what paths it needs to build, and then it will go out and fetch any sources that it needs to fetch ahead of time. And then after it's fetched all of the sources, it won't allow the Nix package packager to builder to actually retrieve anything else from the internet, because that will violate referential transparency, right? You need the sources first, right? But after that point, it isn't actually going to the internet and retrieving more information that may impact the state of the package later on. And then at the bottom here, we just launch the Erl shell, and we get the version that we expect, which is Erlang OTP 17. And then here we can do the same thing, except we're loading an environment with just the Erlang R18. And at the bottom here, we load the Erl shell, and it gives us OTP 18, right? Which is what we expect, right? Even though you can install these consecutively, and it will result in the same thing, right? So you can install multiple versions of Erlang or whatever, like Ruby. Who here's managed Ruby, the multiple versions of Ruby in production? Anyone? Yeah, who loves it? Yeah, so I've had a lot of luck with Nix packages with different versions of Ruby, and I would not go back, right? I would not go back. So, okay, so that was a trivial example, right? So we'll have a look on the next slide of a shell.nix expression, right? But for now, we're going to just invoke Nix shell, which is going to load up that shell.nix file. And that's all we have to do here is lock down the version of Nix packages that we use, right? Which we're doing by adding this channel. And then once we add that channel, and it's in our path appropriately, then we can just run Nix shell. And then anytime that we load up the same shell.nix expression that I'll show you in a minute, with the same channel version, we'll get the exact same environment. There will be no difference whatsoever. So let's have a look at this shell.nix. So it takes a little bit of getting used to the syntax, but the very top, we're just defining a named list of arguments, and the question mark there is just saying if packages argument is not defined, then we import the current version loaded in the environment of Nix packages, right? This is a shorthand, this is a default kind of thing, right? So assuming you've locked down your versions, your channels versions, this will not be a problem. But if you don't lock down your channel versions, you don't want to do this, right? Oh, sorry. Did you have a question? Oh, okay, so Nix packages, sorry, the Nix packages package set, if you will, is what is it? Is a channel. It's equivalent to an apt source or a yum repository. Thank you. Yes. And so anyway, so here we're defining build inputs, right? And we're saying we want full Git version, right? With all of the utilities with Git, right? We want Scala and SBT installed, right? And assuming, and Postgres and maybe some Elm packages, right? And assuming that we've locked down our channel version, right? Then we will get the exact same versions of all of these things and all of their transitive dependencies, right? So this is actually a repeatable dev environment. Now, inside of the same Nix expression, it didn't fit on the slide, so I'm extending it to this slide. There's a shell hook attribute that we can set, right? And here we're just embedding some kind of shell command, right? We're defining, you know, the service port, database port, or whatever. You can do other things right in here. Basically, if the database path doesn't exist, then we're going to do the initdb, and then we're going to start Postgres, right, using that database path, right? And okay, so now consistent CI dependencies. So who here manages like CI builders or Jenkins slaves and that kind of thing? Yeah. Who loves managing those? Yeah, that's my opinion too. So we had to make, so you could use Hydra, right, if developers don't get all crappy with you, right, and say, I'm used to Jenkins, don't take my Jenkins away from me. But in our case, we had to use Jenkins and use our own builders, which were running NixOS. And what we are able to get from that is that we can use this thing called Nix shell as a shebang, right? So we were using Nix shell previously to get the repeatable dev environments, right? And to load in an expression that defines all of the dependencies that we would want, right? To be able to develop in. And here we can say, well, this script only requires Scala, SBT, and Postgres. And we want our script to be written in bash. So we don't have to define our like our verify scripts or whatever in Nix, right, or anything crazy like that. We can have them change the interpreter to be Ruby if they wanted this to invoke some kind of rig task or something like that, right? And so let's have a look further on in the file. And this is just a bash script, right? This is not too interesting. Again, we do something similar where if the database path isn't created, then we init the DB, and then we do like an Elm make to make to transpile to JavaScript, our front-end stuff. Maybe we do some kind of SBT clean and Scala style checks, right, on our project. And then we would actually start the database, right? And then maybe we would run some, sadly, integration tests, right? And then we would stop Postgres, right? So, okay, so as long as we pin our channel versions down, we get source and CI consistency. So in our case at Lookout, we actually put all of our CI stuff, CI scripts inside of the repository itself, alongside the application source. We also put all of our infrastructure definition in a specific convention, like directory setup inside of the same repository, right? So application source and infrastructure changes can happen in the same git commit, right? And there's a nice kind of atomicity about that. And we update the CI build dependencies alongside the application code, right? So we don't have to say, oh, well, I'm trying to upgrade Ruby, right, in this MRI application, so I have to make all these changes to the source code maybe, and at the same time I have to like go and do some out-of-band sort of like chef converging or something like that on the CI build host. That's no longer a thing, right? It was for a while, right? And, okay, so, so one thing that we can do, right, is we can diff dependencies. So we can actually have a look at all of the dependencies of my particular Scala project, right, and it'll list all of the transitive dependencies of the paths that it requires, right? And so what does this give us, right? Well, it can give us more predictable deploys in the sense that we can deploy or we can project what paths will be calculated, right? What will actually be deployed in some undeployed change, right, to our infrastructure. And then see exactly what packages have actually changed, right? And this is really useful for a number of reasons, right? We might notice that the JVM changes all of a sudden, and that may not be a good thing, right? Or it may be unexpected, in which case you should like track down exactly why that is the case, right? But it gives us better transparency by being able to do this kind of diffing on the dependency path tree. We can also test node configuration inside of the VM, right? NixOS, which is the OS part of the Nix ecosystem, builds a whole bunch of VMs that we can then run tests against, right? And we can test module logic if we've got custom module logic, and we've got, we can do some security auditing that I'll highlight in just a minute. So the machine configuration, it's again a Nix expression. We're basically trying to set up, we can set up some syscontrol settings, right? Just using this really simple expression language. We can do some kind of networking firewall stuff. We could specify the ports that we wanted to enable for TCP opening. We've defined an expression inside of the let above that creates a whole bunch of NTP host names that we can then assign later on to the services.ntp servers attribute. And then we can enable Zookeeper if we wanted to. We could specify our certificate files with some internal CA kind of certificate if we wanted to. And, you know, simple things like time zone, right, for the server, right? Which, this one should be non-negotiable. But if you don't set this, you get some weird time zone, and I don't remember what it is. But so you really should set UTC as your time zone. So you can test your machine configuration by generating a VM, right, and testing it locally. And you can incorporate this, of course, into your CI hooks, right, which you should be doing. And in fact, we do have, right, at Lookout. And so anytime that you've got major host changes, you want to be able to see how things kind of play out. You can do this. Basically, you're just rebuilding NixOS using a particular configuration file, and it builds a VM, and then you can run it locally. You can also push this to a particular test host, as long as you have SSH access and all the required permissions on that host. So the commands are almost identical, except you're providing a target host argument here. So we could, for example, Elasticsearch, right? We would just do elasticsearch.enable equals true, right? We can specify the JRE. Oh God, this is typo, sorry. So you would specify the package, sorry, the first one should be package, so you can specify what version of Elasticsearch you want to run. You can specify the JRE for Elasticsearch to use. And this is a module that we wrote internally. There is an Elasticsearch module that doesn't have quite as much of these things. Now that we've tested it in production, we might actually release it into Nix packages, right? And then here, we're just specifying a list of data directories that we want Elasticsearch to use, right? So this makes it fairly easy to actually consume these kind of configuration modules for different kinds of services and things like that. And then if we wanted to test the behavior of this NixOS module, we can write some Perl. I know, I'm sorry. This is Perl, right? But I haven't seen anything that allows us to do infrastructure integration testing with quite the same amount of coverage that the NixOS environment does. And I've looked at a whole bunch of things from server spec to other things. This kind of gives us a lot more coverage in terms of the amount of behavior that we want to specify and assert. And so security auditing, we can actually find all of the things that we depend on for this particular package, right? Now that would be like /nix/store/ something, right? And we can actually just see, is it using anything that is troublesome from a security perspective, right? We could also look at what depends. We can do the reverse lookup. What depends on a vulnerable OpenSSL, obviously, right? And things like that, right? Which is very, very useful. And again, here we're looking at all of the OpenSSL packages that are installed. And actually, I think at this point, since I've written these slides, that is actually not a good version, but I've never had a problem with Nix packages not keeping up to date with those kinds of updates, security updates and stuff. So some of the trade-offs are provisioning isn't totally solved, especially in AWS. NixOps may be quite good in other kind of clouds and stuff like that if you don't need to be AWS specific, but for us it's not really great. But at the same time, tools like Terraform, they give us the coverage, but they don't give us the expressiveness that we've found using Nix expression language for defining things. So for example, being able to stripe over all of the availability zones in our region. So there's one region we use that only has 2 availability zones for us, right? And other ones have 3, right? Using Terraform, we actually had to come up with 2 different templates, right? That's not very expressive. But with NixOps, would be able to stripe over them programmatically in a very simple way, right? It is a little bit of a steep learning curve. The documents are really great for reference, but they're kind of not great for people that are new to the environment. That's slowly changing, and I'm trying to document this more based off of feedback I've gotten from internal users who are kind of ramping up. And I'll talk a little bit about that project in a minute. So and then it does require some upfront setup, but so does, if you do it properly, like setting up Ubuntu with internal sources and things like that, and having some kind of deb package building process and stuff like that, right? So this is actually not any different from doing it properly in the other environments. It's just that you get away with not doing it properly in the other environments. And then, so the benefits are we now have repeatable environments for the services that we have converted. We have consistent CI dependencies. And we can do more predictable deploys, right? And as a consequence, we can actually get, on the host level, on the node level, real rollback support. I don't know about you, but anytime I've done yum downgrades, I cross my fingers and I hope everything goes all right, but typically that doesn't happen. And so the win is that it's really simple at its core. It's just learning all of the different tools around it. But it's really just an expression language that allows us to specify these things. And so what's next? We need to improve Nix AWS provisioning. I'm trying to work on an IDRIS backend because I like types and I miss not being able to use types properly. And so also, if anyone's interested in doing a Nix BSD, please let me know. I am interested in that. And this was something that was circulated as a weird idea, but you could have Nix compiled to JVM bytecode that could then do a whole bunch of things like have your deployment for a specific version of a service available for you anytime, right? And so then you can execute it and you can run various kind of, maybe with IDRIS Nix backend that wouldn't be quite so necessary, but you could do some kind of linting things on your infrastructure perhaps. Okay, so where to go to find stuff out? There's a NixOS manual and the Nix manual. They're in fairly simple URLs. I'm starting a Nix cookbook, so to make things a little bit more accessible for people with experience with Ubuntu, CentOS, and things like that. And Chef and Puppet and so on and so forth. And if you search for Nix Pills by Lethalman, you'll get a whole bunch of interesting things on how to use the Nix expression language. So anyway, look out hiring. That's pretty much it. And questions? Yes?
So do you distribute applications as well?
Yes, we do. So we build a package.
So my first question was, do you distribute your applications with using the Nix language and package management?
Yes, we do. So we have an internal. So inside of our deployment script, we just build a Nix package and then we add it to the systemd service definition inside of the Nix expression.
Okay, and my follow-up is, have you done OTP hot upgrades with Nix?
I have not, no. Okay. And I imagine that would be a problem, yes. Thank you very much.